Welcome back to Talk Tensors. Today we're going to take a deep dive into something that's really been catching our eye. And it's this new paper
Oh, yeah.
called T2V CompBench, a comprehensive benchmark for compositional text-to-video generation.
It's a mouthful.
It is a mouthful, but, it's not just about like making cool videos.
Yeah.
This is about pushing AI to understand
Right.
complex instructions.
Yeah.
It's testing its ability to think.
Yeah. Yeah.
Mhm.
Absolutely. And I think the authors really hit the nail on the head with this one. They've created this new benchmark, T2V CompBench, with 1,400 prompts, carefully designed prompts
Follow.
that are specifically meant to challenge these AI models in this specific realm of text-to-video generation.
That's a fascinating.
And the findings are really interesting.
I'm already intrigued. So, okay, let's start with the basics.
Sure.
Why is generating a video from a text prompt, like something like a blue cat chasing a yellow bird that's changing color as it flies past a green tree,
Right.
so much harder than, say, just a red ball?
Well, think about it this way. If you were to give someone instructions to draw something,
Okay.
if you just said a red ball, that's pretty easy.
Yeah.
But if you start adding in multiple objects and, actions, changes over time and spatial relationships, it gets a lot more complicated.
I see. So it's like the difference between, drawing a stick figure and like a full-on Renaissance painting.
Exactly. That's what we're dealing with here. The AI needs to be able to understand not just the individual words in a prompt, but the entire sentence, the entire meaning,
Right.
how the objects relate to each other, how they're moving, how their attributes might change over time.
Yeah.
That's what we call compositionality.
Okay, so how did the researchers even begin to tackle this?
Right.
Did they just throw a bunch of prompts at the AI and see what happened?
Well, not quite. They were very systematic about it.
But-
They broke down compositionality into 7 key categories
Oh, wow.
that each focus on a different aspect of complexity.
Okay, so let's break those down. What are some of these categories and why are they so important?
Okay, so take, for instance, dynamic attribute binding.
Okay.
This is all about representing changes over time. So think about a leaf changing colors, from green to red in autumn.
Yeah.
The AI needs to be able to understand not only that the leaf is changing color, but how that change happens gradually over time
I see.
and realistically.
That's a subtle concept, even for humans,
So it is.
to grasp.
Yes.
It's tricky for AI.
Yeah.
Okay. What about spatial relationships? How does that play into compositionality?
So spatial relationships are crucial for creating these scenes that make sense, visually.
Sure.
So if the prompt says a cat sitting to the left of a fireplace, it needs to be able to get that position right.
Yeah, because if the cat's on top of the fireplace,
Right.
that's not exactly a cozy scene.
Exactly.
Are there any other categories that really stand out?
Well, motion is another big one. It needs to be able to create smooth directional movement that aligns with the prompt. And then there's action binding, which basically means the right object is performing the right action.
I see.
So if the prompt says a dog chasing a ball, who's chasing who?
Right. Right.
It needs to be able to understand that.
Yeah, it's really fascinating to think about all the different layers of understanding that have to go into generating even a simple video.
It is.
From text. It's not just creating pretty pictures. It's creating a coherent and meaningful representation of the world.
Absolutely. And that brings us to another really important aspect of this research. How do you even measure success?
Yeah. You can't just go by whether the video looks good or not. There needs to be a more rigorous way to evaluate whether the AI actually captured all the nuances of the prompt.
Yeah, traditional metrics like CLIP score, which measures how well the generated image matches the text, that's just not sophisticated enough for this. You need to have a much deeper analysis to really see if the AI got all of those compositional elements correct.
So what did the researchers come up with? I'm guessing it's not something simple,
Right.
Like a thumbs up, thumbs down
Yeah,
kind of thing?
no, it's actually quite ingenious.
Okay.
They combined 3 different types of evaluation: multimodal large language models, or MLLMs, detection-based metrics, and tracking-based metrics.
Right.
And each one kind of looks at the video from a different angle and provides this more holistic picture
So-
of how well the AI performed.
MLMs, those sound like, next level
They are.
AI. So like, how do those factor into like evaluating these videos?
So think of MLLMs as super advanced language models that can also see.
Okay.
They can analyze both the text prompt and the generated video
I see.
and judge how well they align, even when those prompts are incredibly complex.
It's like having an AI film critic,
Yes.
but
Yeah.
one that understands like the intricacies
Right.
of filmmaking.
Exactly.
Okay.
And then we also have the detection-based metrics. So these use object detection models to analyze each frame of the video so they can identify and count objects,
Oh, wow.
determine their spatial relationships,
That's why.
and even assess whether the attributes, match the prompt.
So it's like having an AI detective
Yes.
carefully scrutinizing every detail
Exactly.
of the scene.
Yeah.
Okay.
And then finally, there are the tracking-based metrics, and these are specifically designed to evaluate how well the AI handles motion.
Oh, okay.
So they can track the movement of objects throughout the video.
I see.
They analyze its direction, speed, smoothness, and make sure that the generated motion aligns with what that text prompt describes.
So we've got an AI film critic, an AI detective, and now an AI like sports analyst working together
The whole team.
to evaluate these videos.
It is.
I'm starting to think these AI models are under more pressure than a contestant on a reality TV show.
You could say that.
But okay, so like all of this rigor is essential to really understand the strengths and weaknesses of these current text-to-video generation models.
Absolutely.
Okay, so I think we've laid a solid foundation here.
Yes.
We understand why compositional text-to-video generation is so challenging.
Right.
And we've got a good grasp of like how researchers are measuring success.
Yes.
Now I'm dying to know, how did these 23 AI models actually perform?
That's where the real fun begins.
Okay.
And that's what we'll dive into in a part 2 of this deep dive.
All right, sounds good.
Sounds good.
All right, so welcome back to Talk Tensors. Last time, we kind of left off on a cliffhanger.
We did.
So we took a deep dive into, the complexities of this whole compositional text-to-video generation.
Right.
Explored those rigorous evaluation metrics that they're using.
Yes.
And now I'm ready to hear how these 23 AI models actually did when faced with this challenge.
So the researchers tested a mix of open source models and commercial models.
Okay.
So those open source models, those are accessible to everyone.
Got it.
Whereas the commercial models, they often have more resources and computing power behind them.
So it's like David and Goliath, kind of,
It is.
in this competition.
Yeah.
Did any of the Davids manage to hold their own against the Goliaths?
They did, actually. One of the things that really stood out was how well some of the models that were adapted from existing open source models performed, like Video Tetris,
Okay.
Vico, and T2V Turbo V2.
Yeah.
All based on an older model called VideoCrafter 2. And they showed some really remarkable improvements across most of the compositional categories.
So it's not just about building bigger and more complex models.
Right.
It's also about like refining and adapting existing ones
Exactly.
to meet the challenge.
Yeah, like evolution in the AI world.
Yeah, exactly.
And speaking of evolution, there's this newer breed of models based on diffusion transformers, or DIT, and these showed some real promise.
Okay.
In particular, CogVideo X5B.
Okay.
That was a top performer in that group.
Interesting. So it sounds like there's no one magic bullet architecture. When it comes to text-to-video generation,
It seems that way.
it's more about finding the right approach
Exactly.
for the challenge.
Yeah.
Okay, so you know me.
I do.
Were there any like clear winners in the commercial arena?
So Pixverse V3, that was a commercial model,
Okay.
and it really impressed. It consistently scored the highest across almost all the categories,
No.
really showing the power of those extra resources, that
Yeah.
computing muscle.
Yeah, so Pixverse is like the valedictorian of the class here.
You could say that.
But I'm curious, like even with the top performing models, were there any areas where they stumbled?
Yes.
Like what were some of the biggest hurdles they faced?
Remember how we talked about dynamic attribute binding being tricky?
Yeah.
That was a major stumbling block for a lot of models.
Okay.
Like, for example, showing a leaf gradually changing color over time.
Oh, right.
From green to red, a lot of the AIs just couldn't quite grasp that concept
Yeah.
of smooth, continuous change. They might show a green leaf and then suddenly a red leaf, but not the actual transition.
So their understanding of like time and change is still a bit jumpy.
A little bit, yeah.
Okay, what about spatial relationships and motion?
So those proved pretty challenging as well.
Okay.
A lot of the AIs got confused about left and right.
Oh, really?
Yeah, placing objects in the wrong position
Uh-huh.
within the scene. And then when it came to motion, a lot of them struggled to generate those smooth directional movements.
Okay.
You might see objects kind of jerking around or moving in the wrong direction altogether.
So there's still a lot of room for improvement
Definitely.
for these AIs.
Yeah.
When it comes to creating these videos that are not just like visually appealing, but logically and physically coherent,
Yeah.
it makes you appreciate how complex our own human perception
It does.
is, of the world.
Yeah, we take those abilities for granted, but replicating them in AI is proving to be quite the task.
So I'm a very visual person. Are there any like examples in the paper that bring these challenges to life?
Yes, definitely.
Like something that, our listeners can check out to get a sense of where these AI are at?
Yeah, figures 6 and 7 in the paper.
Right.
They're really insightful.
Oh.
They show side-by-side comparisons
Oh, wow.
of videos that were generated by different models for each of those 7 compositional categories.
That's odd.
You can really see where the models excel and where they fall short.
I love that.
And it's really fascinating to see how those different approaches tackle the same challenge.
Oh, cool. I'm definitely adding those figures to my reading list.
Okay.
Is there anything else before we move on from those results that really jumped out at you?
Honestly, I think what struck me most was just the incredible progress that has been made in just a few short years.
Yeah.
I mean, not long ago, the idea of generating even simple videos from text just seemed like science fiction.
I know.
And now we have AI models creating, relatively complex scenes, even if they're not perfect yet. It's really a testament to the researchers and the work that they're doing in this field.
It's true. We often focus on the limitations of AI.
We do.
But, it's important to acknowledge the progress that has been made.
Absolutely.
And this research with this rigorous benchmark and insightful analysis,
Yeah.
it's really helping to pave the way for even more groundbreaking advancements in the future.
Absolutely. By identifying those current limitations, we can then focus our efforts on those areas that need the most attention.
Okay, I'm all ears.
Yeah.
What are some of the big questions that this research raises about the future of text-to-video generation?
Okay, so one comment that immediately comes to mind is, can we overcome these compositional challenges by giving AI like a deeper understanding of the physics of the world?
Oh, that's a really interesting thought.
Yeah.
So right now they're mostly learning patterns from data.
Right.
But you're saying like maybe they need a more fundamental understanding of like how objects behave in the real world.
Yeah,
Like gravity and momentum,
exactly.
friction.
Yeah, all those concepts.
Like the difference between knowing the rules of a game and truly understanding like the strategy behind it.
Exactly. If an AI could not only recognize like a ball and a hill, but also understand how those objects would interact based on the laws of physics,
Right.
then it could generate videos that aren't just visually impressive,
Right.
but like physically accurate and believable.
So instead of just mimicking what they've seen in the training data,
Right.
they could actually predict how those objects would behave
Exactly.
in new situations.
Yeah.
Okay, that makes a lot of sense. So this also ties into a much broader question about the future of AI in general. Like, are the current approaches that we're using,
Right.
like largely based on pattern recognition,
Right.
are those actually sufficient for achieving like true artificial general intelligence?
That's the big question.
Or do we need fundamentally different approaches
Yeah.
that allow AI to reason about the world in a more human-like way?
It's hard to say.
Yeah, those are some pretty deep philosophical questions.
They are.
But it seems like, these compositional challenges that we've been talking about
Right.
in text-to-video generation
Yeah.
might be highlighting some fundamental limitations
Yeah, I think so.
in how we're building AI right now,
It's possible.
which is really interesting to think about.
Yeah, and I think that's what makes this research so exciting. It's not just about evaluating these AI models, it's
Yeah.
about sparking these new ideas and pushing the boundaries
I agree.
of what we think is even possible.
Yeah, it definitely feels like we're at like a really pivotal moment
We are.
in like the development of AI.
Yeah,
And research like this is helping to illuminate that path forward,
it is.
even if that path leads us into like totally uncharted territory.
Yeah.
But before we wrap up, what about our listeners?
No, yeah.
Like, what can they do
Right.
with all this knowledge?
Well, first of all, I definitely encourage everyone to check out the full paper. It's packed with so much detail about this benchmark, the evaluation metrics, and the specific models that they tested. And then if you're feeling adventurous, why not try out some of these text-to-video tools yourself?
That's a great idea.
Yeah. see what you can create.
Yeah.
Explore the limitations.
Yeah.
And you never know, maybe you'll come up with some brand new ideas for pushing the boundaries even further.
That's a great suggestion. It's easy to get caught up in all the technical details, but, the real magic happens when people start experimenting with these tools and, bring their own creative visions to life.
Exactly.
So do you have any final thought-provoking questions
I do.
for listeners to ponder?
Here's one that's been on my mind. If AI struggles to represent the dynamic, ever-changing aspects of our world,
Okay.
does that mean that there's something unique about how we as humans
Yeah.
perceive and understand reality?
Oh, wow.
Or is it just a matter of time before AI catches up and maybe even surpasses our abilities in this area?
That's a question that could keep us debating for hours.
Yeah, it could.
I think I'll leave our listeners to grapple with that one on their own.
Okay, sounds good.
Well, thanks for joining us on this deep dive into the world of text-to-video generation.
It's been my pleasure.
It's been enlightening, thought-provoking, and dare I say, even a bit inspiring.
I agree.
So until next time, keep exploring, keep experimenting, and keep pushing those boundaries of what's possible with AI.
Sounds good.